So today what we're going to do is chapter 3, section 4, find and use slopes of lines. First of all, let's look a little bit at slope and see what this means. So slope, a lot of times you see it as rise over run. And what that means is it's the up and down over the left to right. Slope also has a special formula, and that is y2 minus y1 over x2 minus x1. Let's take a look at some ideas of slope. If I take a look at the first graph, you will notice that the slope here is going down from left to right. It's going like downhill. And so the slope on this is negative. The second graph, you'll notice that if I go from left to right, it goes uphill. So the slopes on this one is positive. This next graph, you're going to notice that from left to right, it doesn't go up and it doesn't go down. And so the slope on this would be 0. And think of it this way: if I had a person walking on this line, it takes 0 effort to walk this line. And then finally, this slope on this line, you're going to notice that it doesn't go up from left to right, it doesn't go down from left to right. The slope on this we call undefined. And if you think about it, there's a person that wants to walk this line, they can't do it. Okay, you can't go up or down that line unless you were like Spider-Man. So we call that undefined. Now let's take a look at some examples of slope. Notice on this example, there are 2 points. And so if you remember from algebra, what we did was we called this point 1. And so if I labeled the ordered pairs, I would call this xy or x1, y1. And the 1 is because it's point 1. The second point, we're going to call this point 2. And so I'm going to label this x2 and this one y2. Now, it really doesn't matter whether you call this one point 1 or this one point 2. What matters is that if you label this x1, this one is y1. Okay, so you got to keep it the same because it's 0.1. So let's go ahead and let's look at that formula. So m equals y2 minus y1 over x2 minus x1. And we're going to use this formula to help us to find slope. So the y2 in the point is -4. So I'm going to go -4, and then I'm going to go minus. And then it says y1, which is 0. So I'm going to put in my 0. And then I'm going to grab x2, which is 12. And I'm subtract x1, which is 6. So really what I'm going to do is I'm going to use this as a recipe and a formula and plug in the points that I just labeled. So let's go ahead and clean this up. I end up with -4 over 6. And that gives me -2/3. Notice how I'm leaving this as a fraction, rise over run. This would never be a decimal, 0.06 or 0.6, I mean. You never write that as a decimal. You always write it as a fraction, a number over another number. Let's go ahead and let's do the second point. So this one, I'm going to label this point 1 and this point 2. And so when I do this, this is x1, y1. This is x2, y2. M equals y2 minus y1 over x2 minus x1. So my y2 is -8 minus my y1, which is 3, over x2, which is 2, minus 14, which is x1. And I end up with -11 over -12. And I'm going to clean that up because a negative divided by a negative is a positive. So I end up with 11 over 12. All right, so that's finding slope if I have two ordered pairs. Now, one thing to keep in mind, if I ever had the slope being 4/3, you're going to leave it as 4/3. What a lot of students want to do is they want to make it 1 1/3. Do not do that because we're doing rise over run. So you're going to leave this as the 4/3. Let's keep going then. Slope intercept form, if you remember from algebra, is y equals mx plus b, where my m is my slope. So the number in front of the x is my slope, and the number that's off to the side is my y intercept. So let's go ahead and let's take a look at this first equation. You're going to notice that it's in this form y equals mx plus b. So the number in front of the x is my m. So I'm going to go ahead and I'm going to pull that out. Make sure that you pull that out. So you're going to make sure it's in y equals mx plus b form. Pull out your m, say m is this. And then pull out your b. The b would be 4. So make sure you label those as you're doing them. Now, when we graph, we always start off with our b first, and that is the y-intercept. So I'm going to go ahead and I'm going to mark up my paper. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. This is x. This is y. Now you can make your own graph paper on your paper, or if you want to download some other graph paper from the internet, that is just fine. Make sure that you use hash marks when you graph, and the hash marks are the things that I just marked. Make sure that you mark those down so that we do a really good job with graphing. So again, when we graph this, we're going to start with our b first. Our b is 4, so I find my y axis, which is right here, and my b is going to be 4. So I'm going to find it, and this is where it's 4. And then you're going to notice that my slope is -3/2. So I always have my numerator be negative and not my denominator. It's not going to be both are going to be negative, but I tend to have that negative in the numerator. So I either go up and down and then over to the right. So I'm going to go down, and I'll use the highlighter to kind of help you with this. I'm going to go down 1, 2, 3, and I'm going to go over 2. Okay, so 1, 2, 3, over 2. So I'm going to put a point there. And then I'm going to go down 1, 2, 3, and I'm going to go over 2. And I always do 3 points. So I'm going to go ahead and I'm going to graph my point. And you're going to notice that the slope is negative by looking at it. And you can also see that the fraction was negative. So it makes sense that it goes down from left to right. Now let's go ahead and let's move on to this one. So I'm going to go ahead and I'm going to put in my hash marks. I'm going to label this as my x-axis and this is my y-axis. And I'm going to go ahead and pull out some information. So m is the number in front of the x is 1/3. And my b is the number off to the side, which is -5. And again, when we graph, we always graph the b first, which is -5. So that would be right here. And then my slope, and again, I'm going to use my highlighter to kind of help you visualize this. It's 1/3. So I'm going to go up 1 and over 3. And I'm going to put my point. And then I'm going to go up 1 and I'm going to go over 3. So about right there. And then I'm going to go ahead and I'm going to graph my line. And it should be nice and straight. And you're going to notice that the slope was positive, and you're going to notice that the red line is going up from left to right. Now let's go ahead and let's graph this last one. I'm going to put in my hash marks. Okay, my m is the number in front of x. Now you're going to notice that it's 2. And it's kind of hard to do slope when it's just 2. So I'm going to put it over 1. So if it's a whole number like 2, just put it over 1. And then my b is the number off to the side, which is 1. So I'm going to go ahead and I'm going to grab my 1. And then I'm going to use my highlighter. Again, you don't have to use the highlighter part. This is just to help you. It's positive 2 over 1. So I'm going to go up 2, left 1. And I'm going to go up 2, left 1. And I'm going to draw my line. Notice that I'm putting arrows on the end of it because it keeps going. So now here's a question. What has the steepest slope? So when you're looking at the slopes, again, you're going to notice that the blue was m equals negative 3 over 2. The red was m equals 1/3. And then the green was m equals 2. Now or 2 over 1. What you're going to look at is not necessarily if the slope is positive or negative, but really what is the value, okay? So if I take a look at 3 over 2 or 1 over 3 or 2 over 1, the steepest slope would be 2. So that is the slope that has the highest or the steepest slope. Let's keep going and let's talk about parallel lines. Parallel lines are lines that will never intersect. And so if they never intersect, I know that their slopes are the same. So an example would be if m is 1/2. If I'm looking at parallel lines, the new slope is still going to be 1/2 of the other line. If I talk about perpendicular lines and their slopes, that is the opposite reciprocals. In other words, if m is 1/2, if I'm going to do something that's perpendicular, that upside down capitalized T means perpendicular, what I'm going to do is I'm going to flip the fraction and make it 2 over 1, and because it was positive, this one would be negative. Another example, if m is, let's say, negative 3, and I do perpendicular, I'm going to flip it, so it's like negative 3 over 1. I would flip it and make it 1/3, and because it was negative, this is positive. So those are some examples. And if I multiply them together, if I take 1/2 and I multiply it by negative 2 over 1, I end up with negative 1. So anytime you multiply the slopes of two perpendicular lines, you're going to get the product of negative 1. Let's take a look at this. They're asking me if I have two lines, would they be parallel, perpendicular, or neither? And so let's take a look at these lines. I'm going to do line 1 first, and so I'll do it in red. I'm going to take this as point 1. Take this as point 2. This is x1, y1, x2, y2. And remember that formula was m equals y2 minus y1 over x2 minus x1. Notice they didn't give me a graph. If you were doing an ACT, you wouldn't want to sit there and graph this thing. You're going to actually want to use this formula. It goes a lot quicker than graphing, and sometimes graphing isn't a good visual. So I'm going to take this then and I'm going to put it in there. My y2 was 7 minus y1, which is 5. I'm going to take my x2, which is 0, and I'm going to subtract my x1, which is 2. So I end up with 2 over negative 2, which is negative 1. I'm going to reduce it, or negative 1 over 1. Now what I'm going to do is I'm going to take this line 2, and this again is point 1, point 2, x1, y1, x2, y2. I'm going to grab that formula again. So my y2 is 8 minus 9 and 5 minus a negative 2. So I end up with negative 1 over 7. And you'll notice that these two equations, they're not the same, so they're not parallel, and they're not opposite reciprocals. So they're not equal, and their product is negative 1. So these two lines are neither. They're not parallel, and they're not perpendicular. They're neither. Let's take a look at this. It's asking me, what is the slope of a line perpendicular to? So what they're asking for is, if I have this line that's like this, let's say I graph that, and that's what that line is. They want to know what is the slope that's perpendicular to this line. So if I were to do another line and this was perpendicular, what would be the slope of that red line? That's what they're asking. So what you do is, this blue line, the slope is 4, or like we said, 4 over 1. And if we wanted to look at a line that's perpendicular to it, we're going to take the slope, we're going to flip it, which would be 1 over 4. And because the 4 over 1 is positive, this would be a negative 4 over 1. Now let's take a look at B. B, the slope of B is the number in front of the x, so it's negative 3/4. And this new line, if it's going to be perpendicular, I'm going to flip it, so it's 4 over 3, and because this is negative, this would be positive, so I don't have to put a sign out in front at all. All right, that is it for today. If you have any questions, please feel free to let me know. Otherwise, good luck on this section.